Good morning, students. Okay, so here I am discuss the solution of JEE Main test paper, which is held on 22nd of January 2026 in the morning session. Morning session means shift 1. Okay, so let's start with the first question. Okay, so very good. First question is from kinematics 2D, projectile motion. Okay, in the last test, like 21st January, there was no question on projectile. Now we have projectile motion. So what it says, a particle is projected at an angle of 60 degree with the ground and the projectile makes an angle of 45 degree with the horizontal. Find speed becomes 20 meter per second. Find out its initial velocity. Fine. So quite simple question. They are talking about a projectile which is being projected from ground, and when it is making an angle of 45 degree, at that instant the velocity is given to you as 20 meter per second. Whereas they are asking the initial velocity of projection and the projection angle is 60 degree. So very simply we can do this. We know the property of projectile that its x component of the velocity is never changes. The reason is we are talking about projectile under gravity. So when it is under gravity, the acceleration is only in the y direction, which is minus g. If I am choosing the direction as minus as per the sign convention, that means there is no acceleration in the x direction, which makes its x component of the velocity remains always constant during the motion. So therefore, using this property, we can directly write down u cos 60 degree, that must be equals to v cos 45 degree. Okay, x component at both the instants becomes same. So u becomes u into 1 by 2, that is equals to 20 into 1 by root 2, gives you 20 root 2. So the correct answer for this question is 20 root 2, option A. Okay, move to the next question. Okay, superposition. So we have to find out the electric field superposition due to 4 charges. For such type of question, when you have the diagram and multiple charges, always try to see the symmetry first and try to reduce the calculation by the symmetry. As you can see that the charges are placed on the circle diametrically opposite. So they are making two pairs of diametrically opposite points. So if you see, then this plus q and this plus q, their effect means their electric field will be cancels out each other. So for the resultant field, I don't need to consider these 2 charges because they are diametrically opposite and cancelling each other effect. Whereas these 2 are giving you the field. So when I'm going to write down the field because of the remaining 2 charges, then one thing we need to know that they are giving you the field both in the same direction, because of plus q you are getting the field in this direction, and because of minus also you are getting the field in the same direction. From plus it is away, from minus it is towards. So E1 and E2 both are same. Magnitude wise, if I named it as 1, if I named it as 2, so magnitude wise E1 and E2 both are same, which is kq by capital R square. And not only same, the direction is also same for them. So direction wise also they are same. So that means my resultant field is going to be magnitude wise 2 kq divided by r square, and its direction will be, the direction of this magnetic field is, as per the diagram you can see, it will be making 30 degree angle with the negative x-axis. It is making how much angle? 30 degree with the negative x-axis. So once you know this ER, how to write down in the component form? Like with this magnitude, I have to multiply cos 30 degree minus I cap and sin 30 degree j cap. So it is minus of cos 30 degree I cap plus sine 30 degree j cap. Right? That is your ER in the vector form, which is 2kq by r square is the magnitude and direction will be this. Alright. So, cos 30 degree is root 3 by 2, 2 cancel. This is 1 by 2, 2 cancel. So, it is kq divided by r square. This will give you minus of root 3 I cap plus j cap. That will be your right answer. And if you see, the second option kq by r square is common, remaining term is root 3 I cap plus j cap. So option B is the correct option for this question. Okay. So quite a simple question. If you logically handle it and see the symmetry, it will be a very easy one. Otherwise, if you are taking these two together and then try to superimpose them, it is a bit difficult, but just cancels out by the symmetry and take the effect of the remaining two. Let's move to the next question now. Okay. So, heat conduction, question of heat conduction. Generally, question of heat conduction, when they are asking the temperature of the junctions, we always use the analogy of electrical circuit with this. And as you know that the heat current is given by delta T by thermal resistance R through any rod. The value of thermal resistance will be given by L by Ka. Here we have seen that there are some rods which keeps connecting with them and making some circuit. So instead of dealing with K and A, I am just assuming, let us say L by 3Ka is R. For the first rod, if you see the first rod, the first rod, for this, if I assuming that is, let us say R, then what is the value of R? The value of R becomes L by 3Ka, because it is reciprocal to K, that's why 3K belongs to R, that means K belongs to 3R. So this is corresponding to the thermal resistance R, this is corresponding to the thermal resistance 3R, this is corresponding to thermal resistance 3R, this is corresponding to R, and this is 3R. This way, if I calculate its R equivalent of this circuit, these two are the upper and lower, this is 6R and 2R, so they are in parallel, so 6R into 2R divided by 8R. This is giving you 3 by 2. 3 by 2 R plus this 3R and R is in series, so 3R and R is in series. That means it is going to give me 3R by 2 plus 4R, which is 11R by 2. Okay, let me change the ink, it is more visible. So it will be giving me the equivalent R of this circuit as 11R by 2. Corresponding to that, the heat current will be delta T by R equivalent. Delta T by R equivalent. Now what is your delta T? This is your T1. This is your T2. So delta T will be 100 minus 40 divided by 11 R by 2. Gives me 120 by 11 into R. This will be the heat current. Now let's talk about the temperature at A and B. So for this, for calculating this temperature, I am going to write down the equation for the first rod. Now first rod, this end will be at 100 degrees centigrade. This end will be, let us say, at the temperature TA. This resistance will be R and heat current is flowing with the magnitude H. So here we can easily write down delta by Ohm's law. Delta V is equals to IR. Similarly, it is delta T is equals to HR. That means what is your delta T? 100 minus TA, that is equals to H into R. Now what is the value of H? 120 by 11. So it is going to be 120 by 11, RR cancel. And that's why this TA becomes 100 minus 120 by 11. So 1100 That means 1100 minus 120 is 990 by 11. Approximately this value is giving me by 980 by 11. So 980 by 11 gives me 89 degrees centigrade. The temperature of end A is 89 degrees centigrade. The same way you can make it for the second rod, though I don't need to check, because if I get TA, the TA is matching only with the third option. So directly you can tick without even checking the TB. And the correct answer is C. But even if you want to check for TB, by the calculation, otherwise save your time. Once you get the one option and it is only matching with one of the given option, no need to check the second one. But if I want to check, let us consider the rod which is having the junction B and the end 40 degrees centigrade. So the last resistance, which is of resistance 3R, this end will be considered to be as TB, this end will be kept it as 40 degree centigrade. Again, same thing, delta T is equals to H into R. So delta T is equals to H into R, here R is 3R. Now clearly, since the heat current is flowing from higher to lower, so TB is higher and 40 is lower, is equals to HR. Now HR value is 120 by 11 into 3, so it is 360 by 11. And solve this, you will get TB is equals to 73 degree centigrade. Okay, so a good question, a moderate question, because some of the calculation is lengthy, like directly you cannot see, you have to solve. You have to solve the proper circuit and solve it. So I kept it in the category of moderate. Okay, let's move to the next question. Moving to the next question, the next question belongs to optics. Okay, again, this is the question which is also needed a lot of calculation in this. So first let's try to make the diagram of this question, what it's trying to say. So they are giving you two cases. What are the cases? A convex lens of focal length 5 cm and concave lens of focal length 4 cm are placed in contact. Means what is your first situation? That there will be a convex lens and there will be a concave lens which is kept in contact with the focal length f1 is equals to 5 cm and f2, since it is concave, I write down as minus 4 cm. An object is placed 10 cm from the system. So there is some object which is placed at a distance of 10 cm from this system. In this arrangement, the magnification is m1. Okay, so in this case, magnification is m1. So before I move to the second case, let me find out the focal length, let me find out the magnification of this. Obviously, for the magnification, I have to replace it by the equivalent lens. And you know that when they are in contact, you can find out 1 by f equivalent, that is equals to 1 by f1 plus 1 by f2. So this is going to be 1 by 5 minus 1 by 4, and it is going to give you f equivalent is equals to minus 20 centimeter. Means this system is now behaving as a diverging lens with the focal length of minus 20. And when you apply the lens formula, you will get V. Because why I want to get V? Because to find out the magnification. So 1 by V minus 1 by U. According to the sign convention, U becomes minus 10 is equals to 1 upon minus 20. That is your equivalent focal length. Just solve this. It is giving you V is equals to 1 by 10 minus 1 by 20 becomes 1 by 20, and this is 20. Is it? 1 by 10 minus 1 by 20 becomes 1 by 20, right? So it is giving me the magnification m1 as V by U, which is going to be minus 2. Does it? Is all the calculations are right? 1 by 5 minus 1 by 4 becomes 20. That's okay. Object is at 10 centimeter. That is also okay. Correct. Minus 2. 1 by 10 plus 1 by 20 1 by 10 minus 1 by 20 is 1 by 20 only. So V is plus 20. So V by U will give you minus 2. Okay, so that means second case. So for the second case, now they are saying, now keeping system as it is a concave lens is moved 1 centimeter away, obviously away from the convex lens. So what is the situation 2? In the situation 2, they are saying there is a convex lens and now the concave lens is moved by 1 centimeter. By 1 centimeter. By 1 centimeter. Okay. So it is moved by 1 centimeter away from the convex. Now the magnification becomes M2. Okay. So object is still placed at 10 centimeter. That means 1 by V minus 1 by U is equals to 1 by F. Now I am talking about only the reflection which is taking place because of refraction which is taking place by the convex lens. So it is going to give you 1 by V minus 1 by minus 10 is equals to 1 by 5. Right? Because focal length of the convex is 5 centimeter, which is 1 by V is equals to 1 by 5 plus 1 by 10, and this is 10 into 3, that means 10 by 3. So V is equals to 10 by 3. 10 by 3 centimeter. Alright. Now for the second refraction, and what is the magnification in this case? The magnification, if I named it as M1 dash, which is formed by the convex lens. So what is this? This is V by U, which means this is 1 by 3. This is going to be minus 1 by 3. Now this is because of convex lens. Here second refraction is also taking place. So second refraction is taking place, for which I have to take this U, because you say V is 10 by 3, which is greater than 1. So somewhere here, after the refraction from the convex lens, the image is formed somewhere here, which is working as an object for the lens 2. So for the object distance, what I have to do? I have to subtract V minus 1. That means it is going to be 10 by 3 minus 1, which is going to be 7 by 3 centimeter. And now I apply again the lens formula. So 1 by V final minus 1 by U. Now U he have to take as 7 by 3 here is equals to 1 by F2. F2 will be minus 4. So here it is 1 by V is equals to minus 1 by 4 plus 3 by 7, which is going to be 28 is the LCM, minus 7 plus 12, and V is 28 by 5. 28 by 5, which is giving you the magnifications by the second lens M2 as V by U. So what is V by U? 28 by 5 by U, which is 7 by 3. That means this becomes 4, this is 12 by 5. And the overall magnification in the second case, that is M1 dash into M2 dash. You know that if two magnifications are continuously happening by the two lenses, the overall magnification is considered to be M1 dash and M2 dash. So how much it is coming? It is coming minus of 1 by 3 into 12 by 5. Right? Into 12 by 5, this is 4 by 5. This value is coming 4 by 5. So 4 by 5. And in the question, what they are asking? They are asking, now we have considered both the cases, they are asking the ratio of M1 by M2. Initially, it is coming minus 2. Now the magnification is coming as minus 4 by 5. And this is giving you the answer 5 by 2. Okay. So some calculation mistake, which is I was expecting also, is happening here. 420, this is okay, 20 centimeter, 1 by V, fine. 20, focal length point object is at 10. That's also correct. It goes on. Okay, here I made a mistake, because see, this is minus, so when it goes here, it is minus 1 by 20 minus 1 by 10. Minus 1 by 20 minus 1 by 10 will give you 20 by 3. Correct? So it is giving you minus 20 by 3, this calculation. This is giving you V is equals to minus 20 by 3 centimeter. Alright, and that is why M1 becomes V by U, which gives you V by U as 20 by 3 by 10. That means this is coming as 2 by 3. 2 by 3. So when it is 2 by 3, then clearly your answer is turned out to be 5 by 6. 5 by 6, which is the right answer for this question. Turn out to be 5 by 6, which is the right answer for this question. So I think it is going with the option A. Okay, it is going with the option A, 5 by 6. All right. Okay, let's move to the next one. The escape velocity from the planet of radius r and the density rho is given by 10 km per second. Okay, escape velocity is there. Find out the speed. Escape velocity from the planet of radius r by 10 and density rho by 10. Fine. So this question, escape velocity, you must be knowing the standard formula of escape velocity for any planet. That will be under root of 2g mass of the planet divided by radius. Up here they are mentioning everything in terms of density and the radius, so I will convert this mass also in terms of density and radius. And how can you write down? You can write down this as density into volume. Since we are assuming the planet to be spherical, that's why it is 4 by 3 pi r cube. So clearly, since we have to compare, so I will see the proportionality. All the values are same except density and the radius. So I can say this is r, and r becomes r square. Outside the root it is capital R and under root of rho. So clearly you can see that the escape velocity will be directly proportional to r and root rho. When we want to compare the escape velocity for the two different planets, what we can say? We can say V dash by V, that is equals to r dash by r into under root of rho dash by rho, as per the proportionality. Now as it is given, this is 1 by 10, this is also 1 by 10. That means the new escape velocity for the new planet, that will be VE times by 10 root 10. Now this is coming 1 by root 10, as V is given to you 10 km per second, but remember the unit, kilometer per second, where the answers are given in meter per second. So let's convert them. So this is 1000 divided by root 10. Now it is converted into meter per second, which is going to be 100 root 10. 100 root 10 meter per second. Alright, 100 root 10 meter per second. That will be my final answer. So option C. Alright. Okay, move to the next one. Quite a simple question, easy question. Next one. Figure shows the meter bridge. Initially, null point was achieved at a distance of 40 centimeter when the resistance of 16 ohm is attached to the parallel with R2. New balance point. Okay, so now you know that this is, let me mark the distances. This is given to you that this is a valence Wheatstone bridge in which the balance point will be at 40 centimeter. Since it is a meter bridge, so if this distance will be 40 centimeter, the remaining distance will be 60 centimeter, because overall length is 1 meter, which is 100 centimeter. That means because of the Wheatstone, by the balance Wheatstone bridge concept, we can directly say here that R1 by R2, that is going to be L1 by L2, and 20 by 60 gives me 2 by 3. Alright, 40 by 60 gives me 2 by 3. Now, further in this question, they are mentioning that when this R2 is connected to one of the resistance in parallel, which is 16 ohm, when this R2 is connected to one of the resistance which is of 16 ohm parallelly, the balance point is shifted to 50-50. Means the balance point is now shifted to 50-50. Means this is also 50 and remaining is also 50. So in this case, whatever is the equivalent of this, because R2 and 16 is now parallel, they are giving you some R dash. That means R1 by R dash, according to the balance meter bridge, what you can say, this R1 divided by this R dash, that will be now 50 by 50, L1 by L2, that is 50 by 50 means 1. That means the value of R1 should be equals to R dash. And it is very easy to find out this R dash because R2 and 16, they are parallel. So 16 R2 divided by 16 plus R2 will be the value of your R dash. So I compare it, it is R1 that is equals to 16 R2 divided by 16 plus R2. Now, two variables are there, two equations are there. So better I will replace the value of R1 as 2 by 3 times of R2. So it is 2 by 3 times of R2, which means this R2 cancel. This is 8. This is 24. 24 is equals to 16 plus R2 gives me R2 is equals to 8 ohm. Whereas, what is the value of R1? It is clearly 2 by 3 times of R2, that gives you 16 by 3 ohm. 16 by 3 ohm. So R1 is 16 by, so okay, don't confuse. Both the values are given. 8, 16 by 3, 16 by 3, 8. That means we have to look out that R1 is 16 by 3. Don't go with the first option. Go with the third option. Okay. R1 is 16 by 3. R2 is 8 ohm. These small observation, if you are in hurry or if you lose your temperament during the exam, you can lose, because the moment you get 8 and 16 by 3, because we have calculated 8 first and 16 by 3 later, generally student will be in hurry and directly mark the wrong answer. So please be careful during the exam. You have to be careful while watching the options also correctly. Okay, let's move to the next question now. Okay, the next question is, the LED will glow with the input of A, B, C and D. Okay, so see, when you are dealing with the logic gates or circuit with the logic gate, and when we are talking about 0 and 1, 0 and 1, 0 is corresponding to low potential, 1 is corresponding to high potential. And for glowing of the LED, which is you can see here, this LED, if you want to glow it, that means P should be at the higher potential and Q should be in the lower potential, so that it will be forward biased, right? Then only it will glow. To glow, it should be in the forward biased, right? For which this P should be at high potential. High potential means this P should be giving me 1. And this Q should be at the low potential, which means the value of Q should come as 0. We will see the combinations and let's try to find out P and Q. Okay, so I'm marking here only. This is A, this is A bar, this is B, this is B bar. Here, this will be AB bar. Alright, whereas here, this is C and D OR gate, this or this, and this is not, so, right, NOR, so C plus D. So what is the value of P? Here P is given by AB bar and Q is given by C plus D bar. Alright, so let's make the table. So if I'm making the table, I just make the table here only, and let's choose one by one all the options. Okay, so I'm making here A, B, P, and Q, these values. 1 minute. AB, we need AB value, we need CD value, and we need P and Q value for all the options. So for the first option, the values are 0, 0, 1, 0. That means what is P? AB will be 0, bar is 1. What is C plus D? C plus D is 1, bar is 0. Okay, so this is the results of first option, which is, I think, is the correct option because we need 1 and 0. That means in this case it will glow. In this case the LED will glow. So your correct answer is 1 only. Okay, I don't need to check the other, but just for the verification, let's check one more. So suppose if I am saying the values are 0, 0, 0, 0, then what is P? AB will be 1 and CD is also 1. So both are at the same potential, it will not glow, right? It will not glow. 1, 1, 0, 0, again it will give you 1, but this will give you 0. So again P will be at the low potential, Q will be at the high potential, LED will be in the reverse bias, will not glow. Last one is 1, 0, 0, 0, 1, 0. 1, 0 means it will give you 1, 0, 0, 0, 0 means it will give you 1, again it will not glow. So correct answer will be first one. Alright. So a good question of logic gate. Generally, logic gate is the chapter in which they are basically asking Boolean algebra. And it's quite easy. On almost all the session, whatever question comes from the logic gate, they are very simple. Sometimes so it is very definition based only. And here this will be like quite calculative. You should know this thing. But very easy and you can easily get the marks. Bonus. This is like bonus marks for you in the exam. Okay, move to the next one. Okay, again one calculative one. This question needs some calculation and integration. Okay, a closed tube filled with the gas is rotating with the angular velocity omega along axis passing through the end A as shown in the diagram. We have to relate the pressure at A and B. Pressure at A and B. So pressure at B in terms of pressure at A. Given that pressure at A is PA, we have to find out the pressure at B. Fine. Okay. Since this is rotating, we clearly can see that there will be a concept of centrifugal force, which will be for different portion will be different. So obviously we cannot directly write down that it is uniform throughout. So what I am going to do, I am choosing some x and dx element. For this dx element, this mass becomes my dm and we are focusing on this dm. This dm is also rotating in a circle. This dm is also rotating in some circle. Right? This dm portion is also rotating in a circle. That means it needs what? It needs the centripetal force, and for the centripetal force, the force which is given by the pressure difference is only the centripetal force. Means from here if the pressure is P, then from this side the pressure will be slightly more, which is P plus dP. So overall you are getting the force on this dm mass as dF, which is given by P plus dP into A area minus P into A. Means it is given by dP into area. This is the net radial force which is making this dm element to move in the circle of radius x. That means this df should also be equals to dm into r, which is x here, into omega square, means centrifugal force. So you are getting your first equation, that dp into a, okay, dm I write down in terms of density and volume. So it is going to be density into volume. Volume I can write down as a into dx into x into omega square. So a cancel. I got my first equation, that dp is equals to rho x omega square dx. Correct? This is going to be my equation number 1. Also, they are mentioning molar mass. This is a gas and it is having molar mass with the temperature T. So we have to relate this parameter with the pressure. That means PV equals to nRT. can also be written as P V is equals to small m by capital M, that is the mass, that is the number of moles into RT, or you can write down P is equals to mass upon volume, which is rho RT by M. Okay, so you also know the ideal gas equation in this form in terms of rho and molar mass. So now this is my equation number 2. If I divide the equation 1 and equation 2, when I divide this equation 1 and equation 2, what I am getting? dP by P is equals to rho x omega square divided by rho RT by M into dx. Right? This rho and rho cancel. This is going to be M into omega square divided by RT into x into dx. This is dP by P. And now a simple integration. So for x equals to 0, the pressure will be PA. At x equals to, length is given to you as L. This is PB. That means you are getting ln PB by PA is going to be your m omega square by RT. This value will give you x square by 2, and after putting the limit, it is L square by 2. Means PV is equals to PA e to the power capital M omega square L square divided by 2RT is your final answer. So I think in the entire question paper, this is the lengthiest question and quite interesting question. Okay, we can keep it in tough category according to JEE Main. So the correct answer is A. Okay, PA e to the power M omega square L square by 2RT. Okay, let's move to the next one. Next question will be, again, it is a question from thermodynamics. Volume becomes 8 times, delta Q is 0. Okay, so delta Q is 0 means what? Delta Q is 0 means adiabatic process, and they are talking about volume change and temperature change. That means for adiabatic process, PV gamma is equals to constant, but I want the relation between T and V, which is giving you T into V to the power gamma minus 1, that is constant. So by the given values, can we calculate the gamma? Yes. So it is, if initial temperature is T naught, initial volume is V naught, gamma minus 1, final temperature becomes 1/4. Final volume will be 8 times of gamma minus 1. That gives you 4 is equals to 8 to the power gamma minus 1. Up to solve this equation, just make it this in the form of 2. So this can be written as 2 square. This can be written as 2 cube, which is 2 to the power gamma minus 1 into 3. Alright, and now compare the power. So 2 is equals to 3 gamma minus 1, or gamma is equals to 1 plus 2 by 3, which is 5 by 3. And 5 by 3 is the ratio of Cp by Cv, means it's the value of gamma for monoatomic gas. For monoatomic gas. Out of the given option, which gas is monoatomic? Helium. Alright, so the correct answer is 4. Rest all are polyatomic. This is, or diatomic. This is your monoatomic. So correct answer is 4. So again, a easy question. Okay, move to the next one. Oh, very familiar, many times in almost in every test, every study material, you have seen this question many times. Okay, simple free body diagram in electrostatics. So if you are making the free body diagram of this block or this pendulum, what are the forces which is acting? This is having mass and charge. So because of the mass, there is a weight which is mg. Because of the charge, there is a force, electric force, which is in the direction of field, that is QE, and the third force will be tension T. So to find out this tension T, we can say since it is in equilibrium, the sum of these two forces will be equals to tension, and sum of these forces will be, these two forces are at 90 degrees. So what will be your answer? Mg whole square plus QE whole square. Alright. Two forces at 90 degrees, their sum will be E square plus B square, which will be balancing the tension, is the answer. So very familiar question. Many times you have done this. Okay. I think most of the students don't even need to calculate this directly. Mark the option. Okay, move to the next one. Fine. There is a glass sphere of refractive index 1.5 on which there is a parallel beam of light falls. Find the distance of the final converging point of the final emergent ray. Final emergent ray. Mind it, this is, they are talking about final emergent ray from the center of the sphere. Okay. So there is a transparent sphere made of glass. This is the central line, the diameter, along the diameter, and there is a parallel beam of light. There is a parallel beam of light. There is a parallel beam of light which is incident on it. So it will be focusing at some point. Okay. So you know that in this case we cannot treat it as a lens because it is not thin. This is completely sphere. That means we have to go for the refraction formula at spherical surface. So here the refraction, when we are talking about final ray means after two refractions. So I will consider two refractions. One is at the pole P1 and one is at the pole P2. And center will be C. And the radius is given to you 50 centimeter. The radius of this sphere is given to you 50 centimeter. So question is simple, moderate question, but while the calculation, you have to be little careful about the sign convention, especially the sign convention, because most of the students made a mistake in sign convention for this type of question. So let's talk about the refraction. Refraction at P1. At P1. Refraction formula is mu2 by mu2. Mu2 means 1.5, mu1 means air. So it is 1. So mu2, that means 1.5 divided by V minus mu1 by U, that is infinity, parallel ray, is equals to mu2 minus mu1 by R. According to the sign convention, for P1, this curvature will be considered as plus R. So this is plus R, which is 50, and we can solve this. We can get V equals to 3R. Is it? V equals to 3R, which is 150 centimeter. So after the refraction, it is, now this total distance is 100, so it is focusing on 150, somewhere here. Somewhere here it is focusing, right? It is focusing somewhere here. That means this distance is 150. From here to here, this distance is 150 centimeter. This is the image which is formed after first refraction. Now this position of the image 1 is behaving as a object for P2. And for this P2, I will take this distance becomes 50 centimeter now. This is 150, this is 100, so this is 50. So let's talk about the refraction which is now occurring at P2. Again, refraction formula. Incident rays is coming from 1.5. So now this will be converted to my mu1 and mu2 becomes my 1. So 1 by V dash minus mu1, that is 1.5 for me now. And according to sign convention, you have to take this U as 50, which is plus 50, because it is on the direction of incident ray. So it is plus 50, that is equals to mu2 minus mu1, which is 1 minus 1.5. And for the curvature of P2, it will be on the opposite side, that's why minus, so it is minus R. This is going to be minus R. This is how we calculate this V dash. We calculate this V dash. So 1 by V dash, that is equals to 0.5. 0.5 by 50, this is coming 1 by 50 minus 1.5 by 50 minus minus becomes plus. This is 2.5 by 50 This is 0.5. 0.5 by 50. This is minus plus 1.5 by 50. This will be 2 by 50. 2 by 50 means V is equals to 25 centimeter. So after the second refraction, the ray is turning and this will be finally focusing at 25. This is your final emergent ray. This is your final emergent ray at 25. But mind it, they are asking the distance of the final emergent ray focusing at 25 from P2, but from the center, this distance Ci is going to be 50 plus 25, which will be 75 centimeter. So 75 centimeter is the corresponding correct answer for this question. All right. So as I told you, this is little calculative, and most importantly the sign convention. If you take care of the sign convention, there is no chance of making any mistake in this question. Okay, move to the next one. Okay, now this question is, because see, you know that this is memory based, so this language might be differ from the actual one. But if I go with this language, and try to find out this correct answer for this, then liquid pressure exerted. Now when we are talking about liquid pressure, you know that first of all pressure is only exerted. So pressure is not exerted, force due to the pressure is exerted. And force due to the pressure exerted, that will be in all the possible direction. That can be inwards, that can be outward, that can be downward, that can be sidewise, that can be any point. So it is on the solid surface also, between the layer also, and along with that, it will be in all the possible direction. So according to me, this particular statement will be, it could be correct if this only is not there. If it is, they are simply writing pressure is exerted on the solid surface in contact and between the layer, is correct. But since they are writing only, this only is the problem, because if it is only, that means it is acting in all the possible direction, not only between the layers. That's why this statement has to be incorrect. For me, this statement will be incorrect, right? While second statement is surface tension arises due to the difference of potential energy of the molecule. Yes, correct. So Fa and Fc, you know that surface tension is the phenomena of adhesive and cohesive forces, which is the cause of potential energy also. And because of this potential energy, the free surface tries to minimize the area, which is the reason of surface tension. So this is correct, that surface tension arises because of the difference of the potential energy between the molecules. So statement 1 is incorrect and statement 2 is correct, which will be my option C here. You might have find out the different opinion about this question. As I told you, it is memory based, and it is memory based. Suppose if this only is not there, this statement can be correct option also, right? But because of this only, I will definitely going with the incorrect option only, because this is incorrect, this is correct, and that's why option is C. The correct language of this question we will get once we get the actual paper from the NT. Then only we can decide the correct answer for this. Otherwise, according to this language, the correct answer should be first is incorrect, second one will be correct. Okay, move to the next one. A rod of mass m and length L is released on the rail placed in a uniform magnetic field. Find out the terminal velocity. Fine. So this is the rail which is moving, which is falling down, and they are asking terminal velocity. You know that terminal velocity is something which becomes constant. Obviously, in this case, we are assuming that this rail are having sufficient large enough. The region of the magnetic field as well as the length of these rails are sufficiently large, so that it is not leaving this loop. So anyway, so Vt is constant, and velocity can be constant only when the forces are 0. The net force on the rod is 0. If I see how many forces are acting on this rod, so definitely since it is the vertical motion on this rod, the one force which will be acting is definitely its weight, mg, and the second force is the magnetic force which is due to the motional EMF as well as the induced current, right? So since the motional EMF will be there, since it is moving down, V cross B will give you the EMF. EMF is in this direction, motional EMF in this direction, which causes the current, induced current in this loop, and because of this induced current, there will be a magnetic force BIL, which is acting in the upper direction. So if you remember the direct expression of this magnetic force, that comes as B square L square V by R, and this will be your mg, and now make the net force should be equals to 0. So if you are making the net force equals to 0, so what is that? That is mg is equals to B square L square V divided by R. BLB by R is I, and BIL, this will give you this thing. So what we have to find out? The terminal velocity, VT. So it gives you mgr divided by B square L square. mgr by B square L square. That will be my correct answer. We are going with option B in this case. Okay, move to the next one. So simple question. Okay, next one. Okay, absolutely direct question from the Bohr's orbit, and they are not even given hydrogen-like atom. They are giving you hydrogen atom, for which you are very well know what is the energy of the first orbit? Minus 13.6 eV. What is the energy of the second orbit? It is minus 3.4 eV. So what is the difference of this energy, E2 minus E1? That is 10.2 eV, right? 10.2 eV. So now this should be your right answer, because they are asking that it is energy required to jump from first to second. That means this is the right answer, but they are asking the answer in joule. So convert this energy, this is the energy which is required, convert it into joule, which is 10.2 into 1.6 into 10 raised to the power minus 19 joule. 19 joule. And we can solve this. So it is coming out to be 1.634. It's coming 1.632 into 10 raised to the power minus 18 joule. Okay. So this is the answer, nearest answer. Okay, digit can be little different. This can be 2. Fine. Move to the next one. So quite an easy question, the previous one. Okay. Okay, this is the exact question. No. Photon is having this mass. What should be the frequency of the photon when it breaks to the 4 alpha particle? Okay. So question on the nucleus, mass defect. So when this photon is split into alpha particle, these masses are already given to you. So mass is given to you as 15.6. What is the mass of 4 alpha particle? Mass of alpha particle is given to you as 4.004 AMU, atomic mass unit. That means 4 alpha particle is having the mass 4 m alpha, which is 16.016 AMU. And now you can clearly see the mass defect, delta M, that will be 16.016 minus 15.356. Alright, this is 0, 0, this is 11 minus 6, this is 996 point. So 0.66 AMU. That will be your mass defect. Right? We have to find out the energy, and that energy will be now converted into the photon frequency. So, okay, so this delta m into c square. What is the energy associated with this? Delta m into c square. That is the energy liberated, which is in the form of photon, which is having the frequency hf. That means when I converted this into the unit, you know that how to convert mc square. We will say 0.66 into 931.5 MeV per c square. So mega electron volt, this is MeV, mega electron volt, this is the energy, divided by H, which is 6.63 into 10 to the power minus 34. One more change you have to do here. What is that change? That this mega electron volt also you converted into the energy. Okay. We got this mass defect as 0.66 AMU. I quickly write down. It is missed out. So delta m into c square, that gives me 0.66 into 931.5 into mega is 10 to the power 6 into EV. So it is 1.6 into 10 to the power minus 19 in joules. Now for the photon, we will compare this to HF. Okay, so for the frequency, we will simply divide it by Planck constant, which is 6.63 into 10 to the power minus 34. Okay, little calculations required here, and just do this calculation. So it is approximately 10, this is 16, 931, it is coming 14.9 into 10 to the power minus 19. Okay, this power is going to 21. So when we convert into, this is 931 into 16, it is in hertz, kilohertz, and this will be coming 14.9. Okay, when we convert into kilo, okay, and consider all the units properly, we will get 10 to the power 90 kilohertz. That will be your answer after calculation. Alright, so first mass defect, delta m into c square, that will be your energy, divided by h will be the frequency of the photon which is coming out during this incident. The correct answer is A. Move to the next one. Okay, dimension analysis. So quickly find out the dimensions of all. Hopefully by 1 or 2 we will get the correct answer. Okay, because it is optional waste. So spring constant, that is K, that is force divided by length, F equals to Kx. So dimensionally if I see, this is spring constant, K will be mLt minus 2, that is force divided by L. Means it is finally giving me mL0 T minus 2. Correct? So for the first one, we are going with the option. For the first one, we are going with the option mL0 T minus 2, means option 3. For second is thermal conductivity. Thermal conductivity Ka delta T divided by L, that is equals to heat current, means Q by T. So for thermal conductivity, dimension wise, this is energy mL2 T minus 2, this is time, which is T, this is by delta T, so delta T means Kelvin, and this L and area, this will be giving you L, so divided by L also. And if I solve this, it is m L1 T minus 3 K minus 1. So m L T minus 3 K minus 1. So clearly you are going with option 2. So 3 and 2, 3 and 2, 3 and 2, 3 and 2. Automatically you are getting the option D. I told you just 2 options are maybe sufficient to find out the correct option. You don't need to waste the time during the exam. Here we can check the other 2 options also, but in the exam if 2 are matching, just go with that. Okay, Boltzmann constant. Boltzmann constant, half kT is equals to kinetic energy per unit molecule. So kinetic energy, that means what is your Boltzmann constant? It is kinetic energy ml2 t minus 2 by t, which is k. That means the dimension formula of Boltzmann constant is ml2 t minus 2 k minus 1. ml2 t. So third option, ml2 t minus 2 k minus 1, going with first one. Going with the first one. And inductance L, that is energy by I square. Energy is equals to half Li square. So it is ml2 t minus 2 upon A2 ampere square. That means ml2 t minus 2 A minus 2. And you can see that this is fourth option is going with the fourth one. Alright, with the fourth one. So correct option is D, which you already got it by checking the first two options only. Alright. So till now it is going very fine. Like few questions are definitely lengthy in terms of calculation. Otherwise, question is simple. As far as the paper level is concerned, I put it again in the easy to moderate category. Not very complex, okay? This is exactly the same question which is repeated in the shift 1. Shift 1 on 21st, the same question is repeated in shift 2. Only there are little bit changes like there is a nucleus, there is a alpha particle which is being projected. In fact, in the shift 1, this kinetic energy is given exactly the same. That was given as 7.7, here it is given 7.9. Now, this is being projected from a large distance and it is just able to reach till the surface. That means it is just able to reach to the surface. It is just able to reach to the surface of this nucleus. That means from the center its distance will be radius. So here, if it is just able to reach the surface, that means velocity is 0. Again, we use the concept of loss in the kinetic energy is equals to gain in potential energy. Gain in potential energy. Loss in the kinetic energy is equals to gain in potential energy, conservation of energy. What will be the loss of kinetic energy of alpha particles? 7.9 mega electron volt. So it is in joule now. That will be equals to gain in potential energy. Initially they are at infinite distance, so potential energy is 0. Now it will be K into, this is 79e, charge on the nucleus is 79e into alpha particle, that is 2e, divided by distance between them is now radius. Okay, so 1e cancel, this 79, this is directly 10. So R value you are getting as 9 into 10 to the power 9 into 10 into 2 into E, that is 1.6 into 10 to the power minus 19 divided by 10 to the power 6. So here R is 9 into 3.2. 9 into 3.2. 9 into 3.2, 18, that is 8. And 27, 288. So 2.88 into how many powers? Powers is 8, that is 11. 11 ke baad this is 16, 17, and this is 16. Alright, this is okay. Once again, powers is how many? This is 10, this is minus 9. Minus 9 goes up, it is 15. Okay, so this is coming 28.8 into 10 to the power minus 10 to the power minus 15, which is going to be 28.8. 10 to the power minus 15 is Fermi. So Fermi meter. So that is the radius, mind it. We have to find out what? We have to find out diameter. Diameter will be 2r. So 2 into 28.8. That is going to be 6.75, 57.6 Fermis. The correct option is A. So if you have seen the shift 1 paper before going to this, you can directly remember this value and double it. And double it, directly it is giving you. So repeated question, I must say. Next is, two disks having the same moment of inertia about their axis, their thicknesses are T1 and T2 and R1 and R2. Find out the thickness if they have, okay, so moment of inertia is same for the disk. Now I for the disk is mr square by 2, but they want to compare the disk with the radius and thickness, and they are made of having same moment of inertia and same density. That means mass is not given, density and thickness and radius is given. So I express the mass in terms of thickness and radius, which I can write down as density into volume, which is pi r square into t. So if I substitute here, what I'm getting pi rho r to the power 4 t divided by 2. All right. Now, if the moment of inertia is same, I1 is equals to I2, that means R1 to the power 4 T1 is equals to R2 to the power 4 T2. What we have to find out? The ratio of thicknesses, T1 by T2, which is going to be R2 by R1 whole to the power 4. R2 by R1 is given to you 2 to the power 4, which becomes 16. So 16 is the right answer for this question. All right, move to the next one. Okay, initially force is on M naught, is F naught. Okay, find out the position of, if the 4m and 3m is changes, then it is F dash. Find out this ratio and find out alpha. Fine. So in this question, interesting question. First you need to understand that again, superposition, and in superposition try to first check the symmetry. You know that the Newton force between the two masses will be G m1 m2 by r square. As far as it is the center, the distances are all same, so I'm not worried about r. I'm only just checking the masses, and this is attractive in nature. So if you see again, they are opposite to each other. The masses which is at the vertex, which is at the corner, will be opposite to each other. That's why to consider the overall force because of them, I will take the overall mass of 4m and 2m. The 4m and 2m will be leaving the effect of only 2m. You know, 1 2m will cancel the each other effect. Similarly, this m and this 3m, this is also leaving the effect of 2m only. So one is this 2m and one is this 2m. Both will give you the same force, say FF. Right? This is a square, so this angle is 90 degree. That means the resultant will be F root 2, which is given to you as F naught. That is given. Mind it, this F is because of the effect of 2m. Okay, overall it is because of 2m and m. So keep this in mind. Now in the second scenario, what they are saying? In second scenario, they are saying that now 3m and 4m interchange, while this m and 2m and this center mass is also remain same. So if I see the overall effect again on this masses opposite to each other, this will leaving with the effect of m, this is also leaving with the effect of 3m. That means this force because of m I can consider as F by 2. This case, because F is corresponding to 2m, so corresponding to m it is F by 2 only, and corresponding to 3m, this force is going to be 3F by 2. You understand? Corresponding to 2m, if the force is F, then corresponding to 3m, this is going to be 3F by 2. What is the resultant of them, which is represented by F dash? That will be, again, these two forces are perpendicular, so F by 2 is common, and it is under root of 1 square plus 3 square, that is giving me root 10 times of f by 2. Here f root 2 will be f naught, so I replace this f by f naught by root 2, and this is root 5 by 2 f naught. Now here they are asking for f naught by f naught by f dash ratio. So f naught by f dash ratio, that is coming out as 2 by root 5. Yes or no? It is coming as 2 by root 5, and since we compare it with alpha by root 5, what is the value of alpha? Alpha value will be 2. That is the second option. Alright, I did not show much of the calculation. This mass is not changing. Only this masses are changing. So corresponding to 2m if it is f, then corresponding to m, I consider it as f by 2. Corresponding to 3m, I consider this as 3f by 2. Okay, no more calculations required. Just superposition at 90 degree. Okay, move to the, so quite calculation is there, but if you stuck in the big calculations, it might be wrong. Just make the symmetry and do it. Next one, two coherent loudspeakers L1 and L2 are separated by 10 meter. Okay, so this is the question of YDSC, but yes, in YDSC we are having the setup in which this D is very, very large. So you cannot use the theory of YDSC, why YD by D and all, because this distance is in comparison to the distances between the slits or between the sources. That's why here to write down the path difference, don't use the direct expressions of YDSC, which is YD by D and all. Here you have to find out this path difference by the actual calculation of the distances. So here if I see, one ray is going from L2 to B, another ray is going from L1 to B. Okay, these are the two rays which are superimposed. If I say what is delta x, what is the path difference between them? It will be L2B minus L1B. What is this distance L2B? What is this distance L2B? So here this total is 10, that means this is 5, this is 5. That means this distance is 5. So 5 plus 25 is 30. Overall 5 plus 25 is 30. To find out this distance L2B, you can directly say it is 30 square plus 40 square, that means 50. And for L1B, if you see this distance is coming as 25 minus 5, which is 20. That means for L1B, you can use 40 square, that is the base, and perpendicular is 20 square. So this value will be 50, this value will be 20 root 5. Root 5 is 2.23. So 50 minus 2.23 is 44.6, gives you 5.4. 5.4 meter, that is your delta x. Alright, 5.4 meter. And they are saying between A and B, there are 10 maximas. You know that every maxima is corresponding to the path difference of lambda. That means 10 maximas are corresponding to the path difference of 10 lambda. So what is the value of lambda here? It is 0.54 meter. Now you know the wavelength of this light, of this sound, and you have to find out the frequency of the sound. Then directly a simple relation V by lambda, that will be your frequency of sound. The velocity is given to you 324, while the lambda we have got it as 0.54. By calculation it will be coming as 600 Hertz. So exact answer is 600 Hertz for this question, sorry. Alright, so don't go with the conventional formulas of YDSC. Why? Because their distances are in comparison to the, all are in the same order. So that's why we have to find out by the geometry, the path difference, and compare with 10 lambda. Move to the next question. Oh, interesting. Okay, this type of question generally students are facing a lot of problem. Okay, for this type of question, just I am giving you one small hint by which you can easily do this. First, fix some observer here and treat these coils as a magnets. So suppose if I am observing here from here and this direction which is given to you anti-clockwise, clockwise and anti-clockwise. So suppose if I with respect to this observer, anti-clockwise direction is this for the coil 1. For the coil 1, this is my anti-clockwise direction. That means if I replace this coil as a magnet, then that magnet will be, is having the magnetic moment in this direction, means this is the south pole and this is the north pole of the first magnet. Alright. While for this observer, if the current will be say clockwise means magnetic moment is in this direction. So if I want to replace this L3 as a magnet, this L3 as a magnet, then for the corresponding magnetic moment, this should be my north, this should be my south, so that I am getting the magnetic moments like this. Yes or no? Now, for the second one, they are saying what should be the correct option, so that the second inductor is also having clockwise. So this is your second coil, and you want in the second coil, you want the current to be clockwise. Clockwise means again you want this to be north, you want this to be south, then only it is clockwise. For anti-clockwise direction, this is clockwise, this is clockwise. So what I did, I will be treating these coils as a magnet, okay, and deciding their poles. It's very simple to see. Faraday's law always says that the motion of any magnet will always such that it produce the effect which is opposes that change, correct? So you want here to be north, and north will do what? Repel. That means this current will be produced in such a way that it wants to repel it. And when it is repelling, it is repelling only when this coil tries to move towards it. If this coil tries to move towards it, then according to Faraday's law, it will oppose it. So for opposing, this should be the north pole. That means where this L1 should move towards. Whereas here, if you see, for corresponding to this north, it has to produce south pole. And south pole means attraction. So to attract it, when it will attract according to Faraday's law? When this coil wants to move away. If it is moving away, then it tries to attract it, just to oppose that change. So by this method, you can very easily see that I can only produce the clockwise current in the middle one when this L1 will be moving towards, and when this L3 will be moving away from L2. So move L1 towards L2 and L3 away from L2. My correct answer is option A. So if you do in this way, you will never confuse. Always you are getting the right answer. Okay? That will be my correct simple method of analysis. Okay. Move to the next one. Fine. Two solid spheres. Okay, minded, these are solid spheres, and we have to find out the moment of inertia about given axis. So moment of inertia can be added or subtracted only when they are about the same axis. So I want, if this is my first body, if this is my second body, if this is the point P, then I want the moment of inertia about point P, which can be only by the sum of moment of inertia of the two bodies about the same axis. So you need the moment of inertia of the first one about P, you need the moment of inertia of the second about P. For a solid sphere about the tangent, what will be the moment of inertia? 7 by 5. So 7 by 5 m1 r1 square, that is for the first one. For the second one also 7 by 5 m2 r2 square. Masses and radiuses are different here. So now I just put the values 7 by 5, m1 is going to be 10, R1 is going to be 0.2, so 0.2 square. M2 is going to be 5, R2 is going to be 0.1 square. Okay, so this is how you are getting 7 by 10. This is 0.04, gives you 0.4. This is 0.01, gives you 0.05, which is 7 by 5 into 0.45. Approx answer is 0.63. Okay, 0.63 kg meter square is the unit of moment of inertia, and we are going with the option first one, A. Okay, almost at the end of the discussion. Okay, next one. If potential is V, which is 500 volts at 10, 20, and electric field is E, which is 10x plus 5 by j cap, find out the potential at the origin. Okay, so you know that the potential can be written as minus Ex dx. Actually, it is delta V, which is minus Ex dx minus Ey dy. Okay, if I am using indefinite integral, I can also put plus C. Instead of delta V, we can take some V minus V naught, which is plus C. So here, V is what? V is Ex dx, that is minus 10x dx. 10x dx will give you 5x square. Is it? X dx is x square by 2. Similarly, 5y, so 5y square by 2 plus C. Alright? That will be the potential expression. Up to find out this value of C, we already have that at 10 and 20, we have the potential of 500. So at 10, 20, you have the potential which is 500. So let me put these values. 500 is equals to minus 5 into 100, 10 square, minus 5 by 2 into 20 square, that is 400 plus C. This way you are getting the value of C as 500 plus 500 is 1000, and plus 1000, that is 2000 volts. So it is going to give me the final expression of my V, which is minus 5x square minus 5 by square by 2 plus C. C value will be 2000. Now, this is your general expression of potential. Wherever you have to find out, you can find out, but they are asking at origin. So for origin at O means 0, 0, just put x and y to be 0. That means, what is my correct answer? 2000 volts. So at origin, you are getting the voltage as 2000 volts. Alright. So good question. So nice question, moderate question. Next one. The energy density at the instant when the current is 1 by E of the maximum value. If the value is alpha pi by E square, find out alpha. Okay. So in LR circuit, what is the maximum current? In LR circuit, the final maximum current will be E by R, which will be here is 10 by 10 E by R. Okay. Is 10 by 10, that is 1 ampere. And they are saying that current will be 1 by E times of the maximum. So it will be 1 by E ampere. 1 by E ampere. Now talking about the energy, U is equals to half. Oh, they are talking about energy density, not energy. Energy density U. So energy density that is given by B square by 2 mu naught. Alright, B square by 2 mu naught. And in case of solenoid, in case of coil, corresponding to I, what is B? So B is mu naught into Ni whole square by 2 mu naught. That means this is going to come as mu naught into N square into I square divided by 2. Alright. So this mu naught value will be 4 pi into 10 to the power minus 7. N is given to you 10 to the power 4. N is number of turns per unit length, which is given to you 10 to the power 4. So square of it is 10 to the power 8. I will be 1 by E, which is 1 by E square divided by 2. Divided by 2. 10 to the power minus 7, 10 to the power minus 8 plus 8, that will give you 10. This 2 and 2 is also cancelled. So 2 into 10 is 20, 20 pi by E square. That will be your energy density. Now if I compare it with alpha pi by E square, then clearly you can see that the value of alpha becomes 20. So this is integer type. What is the value of alpha? 20. Alright. Okay, move to the next question. I think it's the last question. Okay, a ray of light is incident at an angle of incidence I of an equilateral prism. If the rays emerges grazing at the second surface, find out the angle of refraction in degree. Fine. So there will be an equilateral prism, and the ray is incident at some angle I, so it will be refracted at some R1, and then after it will be grazing at the second surface. So if it is grazing at the second surface, first of all, this should be the diagram. This should be the diagram of this question. This is grazing means your E will be 90 degree, and if E is 90 degree, this R2 becomes theta C, the critical angle. Alright, corresponding to critical angle, what is the angle of refraction? That will be 90. So this is root 2. So if I say what is R2, you will say it is equals to critical angle, which is sine inverse of 1 by mu. So R2 will be equals to sine inverse of 1 by mu, gives me 1 by root 2, and 1 by root 2 gives me 45 degree. That means the R2 is 1 by R2 is 45 degree. This prism is equilateral prism. So that means this angle of prism becomes 60 degree as it is equilateral. So we have to find out R1. They are asking find out the angle of refraction at the first surface, means we have to find out R1. You know that in case of prism, what is R1 plus R2? That is equals to angle of prism A. That's why what is R1? It is A minus R2. So A minus R2 means 60 minus 45, which is 15 in degree. 15 in degree. That's why they're asking in degree. What is the correct answer of this question? It is 15. 15. 15. Okay. Okay, so this is the end of the discussion. So hopefully this solution will be useful for you, and this is memory based. So some of the question, as you can see that in the last I discussed only 2 integer type of questions. So some of the questions are, but we discuss all the 25 questions. That means some of the questions are integer type, and all the very best for the coming sessions. And as per now, like what a 4 or 5 sessions is already completed. So as per now, whatever questions are coming, they are very well within the syllabus, easy to moderate range. 160 plus marks is easily giving you 99 percentile, which will secure your NIT seat. And this will also boost up your confidence, so you can work well, you can prepare well for your advanced preparation. Okay, all the very best. Thank you very much.